So hi friends, today we are going to discuss about method of resolution of forces. Okay, నిన్న మనం చెప్పుకున్నాం two methods, resolution of forces and instantaneous center method. So today we are going to discuss about this, and now here we are considering the equilibrium of forces acting at a point D. Here is having the point D acting is here two forces. Okay, I draw here, see this two forces T2 and W by 2. This is resolving. Why? Because the angle is beta, so vertical force and horizontally one time. Okay, now I written this equation like this: T2 cos beta is equal to W by 2, and then we know very well capital W is equal to M into G by 2. So here T2 is equal to capital M into G divided by 2 cos beta. Okay, again considering the equilibrium of forces acting on B, the point B is in equilibrium under the action of the following forces. And now here look at this, the point B is in here. Okay, the force is acting like this and one force is acting like this downward, and here also having the point is coming from here. Alpha is there, angle is called alpha, some angle is there, so we can resolve this force. Okay, we can resolve this force means what happened, one time it will come t1 cos alpha and t1 sine alpha. Okay, and then we are taking from this is two opposite directions, so then we can write simply in here, the resolving forces, resolving the forces vertically. Okay, resolving the forces vertically, T1 cos alpha is equal to T2 cos beta plus W, that is equal to capital M into G by 2 plus mg. This is small w, so I written mg. Okay, and then here T2 I substitute in here, so the value it will come like this. Okay, since T2 cos beta is equal to capital Mg by 2. Okay, and now go for resolving vertical forces is over, and go for horizontal forces. Now resolving the forces horizontally. So then horizontal forces is coming from here, T sine alpha plus T2 sine beta, that is equal to Fc. So now we are going to see in here, see horizontal forces, resolving this one time it will come here. We are going to draw here, one is this thing, so horizontal force here, you take horizontal force is sine, vertical force is cos. Okay, no problem, we can take anything, nothing wrong. Okay, and now here also B, so T1, here also you take, this is cos, this is sine, like that. Okay, and now the force is acting like here, horizontal forces, we take the considering point for this, here is acting centrifugal force horizontally, and here is acting some T1 sine alpha, and here also acting T2 sine beta, and these three forces are acting horizontally. So the three forces we are going to take in here, so this is upward direction, we can take like this. Okay, this like this. Okay, So two forces are in forward direction, one force is acting negative direction. We take this thing is T1 sin alpha plus T2 sin beta is equal to Fc. Now here T1 is equal to T1 and sin alpha plus, but T2 is, we know very well, divided by 2 cos beta into sin beta is equal to Fc. Okay, I substitute this T value in here. Okay, and then we go for here T1 sin alpha plus capital M into G divided by 2 into tan beta, that is equal to Fc. Okay, so therefore T1 sin alpha is equal to Fc minus capital M into G by 2 into tan beta. Okay, and dividing, so here is I am going to see here, this is one equation 1 I put it, that is the first equation, and then here I take some second equation. Where is this? Oh, okay, yeah, this thing is I going to take second equation, and now here is we can take third equation. Okay, now I'm going to dividing equation 3 by equation 2. Okay, then T1 sin alpha divided by T1 cos alpha is equal to Fc minus capital Mg into divided by 2 into beta divided by Mg by 2 plus Mg. Okay, so now here we solve this thing, capital M into G divided by 2 plus M into G. Okay, so tan alpha is equal to Fc minus M into G by 2 into tan beta. Okay, we simply take this inside. Okay, and now calculate this, solve this. 2 plus M into G, that is equal to Fc minus, okay, Fc by tan alpha minus M by G into tan beta by tan alpha. Okay, and substituting, and then substituting tan beta by tan alpha is equal to Q, and tan alpha is equal to R by H. So we have by H. So we have capital M by G 2 plus M into G, that is equal to M into omega square into R, Fc. Okay, and then into tan alpha, that is equal to H by R, so R by H, so 1 by tan alpha is equal to H by R. Okay, minus capital Mg by 2, okay, into Q, tan beta by alpha is equal to Q. Okay, now Fc is equal to M into rho square into R, we know very well. So then here m into omega square into h, that is equal to m into g. Why? Because r will cancel, and plus it will take like opposite direction. So 2 1 plus q. Okay. And then now here we need h. So h is equal to m into g plus capital Mg by 2 1 plus q. Okay, and now here 1 by m into h. So then that is equal to, I'm going to write here, then that is equal to m plus m by 2 1 plus q divided by m into g by omega square. Okay, m plus, and wait. Okay, sorry. Yes, here is omega square. 1 by m into omega square. Right, this is the omega square. H only we can put it. So m into omega square, it will come like here. And then this equation we can write down here, m into g. Okay, not mg. This is m into g. This is gravity. So m by 2 1 plus, okay, divided by m. And then here come to this point. Okay, g, this g you can put it outside, g by omega square. Okay, right. And now we are going to see here omega square is equal to m into g plus m into g divided by 2 1 plus q 1 by m into h. Okay, then we can write this equation, m by 2 1 plus q divided by m into g by h. Okay, so then 2 pi n divided by 60 whole square, that is equal to m plus m by 2 1 plus q divided by m into g by h. Okay, now here we need to find n. N square is equal to m by 2 1 plus q m, okay, into g by h into 60 divided by 2 pi whole square. So then we can return this thing, m plus capital M by 2 1 plus q divided by m into 895 divided by h finally. Okay, so this is the procedure to solve. Now here point మనం గుర్తుపెట్టుకోవాలి, when the length of arms are equal to the length of links and the points P and D lie on the same vertical line. Okay, so then tan alpha is equal to tan beta. Now since g is equal to 9.81 meter per second square, you can take, okay, right. So లేదా మనం ఇక్కడ q is equal to tan alpha by tan beta, that is equal to 1. Okay, so therefore equation 5, where is equation 5 means this is called equation number 5. And now here h, where is h? We find h value, this is equation number 4. H value is equation number 4. And now here we see the equation number 5, okay, becomes n square is equal to m plus m divided by m, that is into 895 divided by h. Okay, so 1 plus 1 2, 2 2 2 cancel, so then here we will get the equation. So second condition, this is first condition, you can take the second condition. When the loaded sleeve moves up and down the spindle, the frictional force acts on it in a direction opposite to that of the motion of sleeve. So if F is equal to frictional force acting on the sleeve in newtons, then the equations 5 and 6, so you can put it, this is 6, so then the equation 5 and 6, if F is equal to frictional force acting on the sleeve, if F is equal to frictional force acting on the sleeve, okay, in newtons, then the equation 5 and 6 is m into g plus capital M into g plus or minus f divided by 2 1 plus q divided by m into g into 895 divided by h. So now here m into g plus capital M into g plus or minus f divided by m into g, that into 895 divided by h. Okay, so now here I put it, this is equation number 7, and now this I put it equation number 8. So that means here when q is equal to 1, since when q is equal to 1, so now here the plus sign is used in the sleeve moves upward, this plus sign, okay, plus sign is moved, the sleeve moves upward, the governor speed increases, and negative sign in used when the sleeve is downwards, the governor speed is decreases. Okay, on comparing equation 6 and 2, equation 2, what's governor, we find that mass of central load m increases, the height of governor in the ratio, the comparing of the equation 6 and 2, okay, equation 6 and 2, and then we will get mass of the load, m, that increases height of the governor in the ratio m plus capital M by m. Okay, so this is the thing, and now we are going to see second method. that is called instantaneous center method. Okay, in this method, equilibrium of the forces acting on the link BD are considered. So then we are going to see here, I am going to draw the diagram of this free body diagram. Now we know very well this is P, B, D, W by 2. Okay, and taken this instantaneous means you can project like this, straightly you can project like this. Okay, and now here we got it W. So this is the ball. Okay, this is ball. We take here is alpha, because of here is alpha, and now this is beta. So then this is also come to beta. Okay, and here to here distance is r. Okay, and now this is T1, this is T2, and here to here is H. Okay, so now the point is called here M, I, and the force is acting, centrifugal force is acting like this. Okay, so now here B and D, okay, forces acting on the link B and D are considered. B and D are considered. The instantaneous center I, okay, lies at the point intersection of PB, produced and a line through D, reduced line D. Okay, ఈ లైన్ ప్రొడ్యూస్ చేస్తే మనకి ఇంటర్సెక్షన్ పాయింట్ ఏదైతే వస్తుందో that is the point is called instantaneous center I. Okay, now taking moments about point A. Taking moments about the point I. So then I point నుంచి మనం ఇప్పుడు మూమెంట్స్ తీసుకుంటున్నాము. ఓకే, సో దట్ ఈస్ కమింగ్ ఫ్రమ్ హియర్ FC is first, FC into BM, right? Okay, and small w into IM, this is small w, so that is the distance. The force is acting like this, horizontal, this is the perpendicular force. We take only perpendicular forces. Okay, BM is perpendicular force per FC, W is IM is the perpendicular force per W, and then plus W by 2 is I into D. W by 2 I into D. This force is acting downwards, W by 2. The distance is DI. Okay, like that. And now we are going to substitute the values in here. WMG into IM plus capital MG 2 into ID. I substitute only W values in here. Therefore, FC is equal to M into G IM by BM plus capital M G by 2 into ID divided by BM. Okay, and then now here M into G into IM by BM plus m into g by 2. So Im plus md divided by bm. Okay, and then we are going to see m into g into Im by bm plus m into g by capital M. Okay, capital M, and then Im by bm plus md by bm. So now here I can write m into g tan alpha plus capital M into g by 2 tan alpha plus tan beta. Okay, I can write this thing. So since I give clear idea, Im by bm is equal to tan alpha and md by bm is equal to tan beta. Okay, so dividing through out by tan alpha. So Fc divided by tan alpha is equal to m into g plus capital M into g by 2, and then 1 plus tan beta by tan alpha. So this is equal to m into g plus capital M by g by 2 into 1 plus q. Now here, since 1q is equal to tan beta by tan alpha, in previous also we take like this, and now we know that Fc is equal to m into omega square into r, and tan alpha is equal to r by h. So therefore m into omega square into r into h by r, that is equal to m into g plus capital M into g by 2 1 plus q. So h is equal to m into g plus capital M into g by 2 1 plus q divided by m, that into 1 by omega square. So this omega square is come here, we need only h. Okay, and then you can write this equation m plus capital M by 2 1 plus q divided by m into g by omega square. Okay, this g. Okay, and same as before, when tan alpha is equal to tan beta, so rq is equal to 1, then h is equal to m plus m by m into g by omega square. Okay, this is the solution to find the h with the help of Porter-Gauner in two methods: instantaneous center method or method of resolving forces. Okay, so tomorrow we will go to see some problems on this. Okay, thank you.